So we need identities for if we want to add two angles for knowing the sines, cosines, and tangents of the sum and differences of two angles. And the first thing to note is if we have the sine of the sum of two angles, s and t, that is not at all the same thing as the sine of s plus the sine of t. That would be too simple, and then we would not need all the following identities. So much in the same way that if you recall the square root of x plus y is not the same thing as the square root of x plus the square root of y. The algebra just doesn't break down like that. So without further ado, here are the addition and subtraction identities for sine and cosine. So there they are. You do not have to memorize these, and you never will have to. They are very difficult to remember. I don't have them memorized. So there they are. The sine of s plus t, what is it? It's the sine of s times the cosine of t plus the cosine of s times the sine of t, etc., etc. So we've got 2 for sine and 2 for cosine. There also are identities like this for tangent, but we don't really need to use them for right now. So let's do an example. So pause this, take a second to scribble all those down, just keep them handy, and we'll see a quick example of what we can do with these things right off the bat. We want to find the exact value of the sine of pi over 12 and the cosine of pi over 12. So we can fill in some of the blank spaces on our unit circle that we haven't been able to find with just basic geometry. So the first thing to note is that it's probably easiest to think about these in degrees, not radians. So pi over 12 radians is the same thing as 15 degrees, because it's just easier to think about subtracting degrees measures rather than radian measures. And also note that 15 degrees is 45 degrees minus 30 degrees. Why is that important? Because we know the sine and cosine of 45 degrees, that's pi over 4, and we know the sine and cosine of 30 degrees, that's pi over 6. So since we know that, we can use what the subtraction identity for sine to get the sine of 45 minus 30, which is 15, or pi over 12. So here we go, using the second one of those identities, the sine of 45 minus 30 equals the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. All right, and we know all that stuff, right? Those are all known angles on the unit circle. So the sine of 45 degrees that's the same as pi over 4, so that's square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2. That's the same angle as pi over 6. Cosine of 45, again, is square root of 2 over 2. And the sine of 30 is the sine of pi over 6, which is 1/2. Square root of 2 times the square root of 3 is the square root of 6, and that's over 4. And so that's square root of 2 over 4. And we can simplify that even further by just combining it into 1. That's square root of 6 minus square root of 2 over 4. And that is what we were trying to do in the first place. That's the sine of pi over 12. So rather than proving these identities, which is very difficult to do, just check that that's true. Just go, sine of pi over 12 on your calculator, or if you're in degree mode, sine of 15, and you're just going to get some decimal and just verify that, yes, that decimal exactly equals square root of 6 minus square root of 2 over 4. So I think I'll leave you to do the cosine of pi over 12. It works out the same way. You're just going to use a cosine identity, the subtraction one. What you end up getting is square root of 6 plus square root of 2 over 4. And you can then use those same exact moves to get all the pi over 12. So like 5 pi over 12, 7 pi over 12, 11 pi over 12. So any of those multiples like that. A direct consequence of the addition and subtraction identities are these so-called cofunction identities. And what these tell you is just basically how sine and cosine relate to each other. And if you think about these graphically, how we can transform a sine graph into a cosine graph. We talked about that when we talked about graphing. So like if you took a sine graph and flipped it horizontally and then shifted it by pi over 2 like that, it would be indistinguishable from a cosine graph. So this is just the algebraic statement of that. But one thing we can do is just prove them. So for example, prove that, let's see, cosine, that first one, cosine of pi over 2 minus t equals sine of t. And the way you're going to do that is with the subtraction identity for cosine. So the cosine of pi over 2 minus t is the same as, okay, if you look at that last identity, the cosine of pi over 2 times the cosine of t plus the subtraction identity for cosine involves addition, and that's why I said these are hard to remember, equals sine of pi over 2 times sine of t. So this is just that identity with pi over 2 and t instead of like s and t. And if you use your unit circle, you see that cosine of pi over 2 is 0. And you'll see that sine of pi over 2 is 1. Which means that first term cancels out and all we're left with is sine of t. Right, so we also have identities like this for tangent and cotangent, but this is what I mean when we say we get a lot of identities for free out of the addition and subtraction identities.